Hi guys, hello everyone. Just finalizing the setup as always. So, guys, if you can see me, if you can hear me, just write you in the chat box.
Guys, if you can see me,
Okay, I
you can
can
hear
hear
me, just
myself
write you
now.
in the chat box.
Hi everyone, hello. Hi guys, hello. Hello everyone. Hmm. So who all are here? I can see Aman is here, Shubham, Piyush Raj, Vikram, Ravindra, Kiran, Shresht, Sachin, Ananya, Jacob, Varun, Siddharth, Tanuja, Shubham, everybody is here. Very well, guys. Very well. Welcome. Welcome back to Vedantu's JEE channel. As always, how are you all? We are all students who are moving from 10th standard to 11th standard. So, even if the schools haven't started, our board results are still to come out. But yes, all those who are aspiring to prepare for JEE 2022. Yes, this is the exclusive time that we meet you all. Thank you, Siddharth. I'm good. Thank you for asking. Very well. I hope all of you are doing well. Yeah, very good. Very good. If there is any JEE 2020 students online right now, you know that your JEE examination dates are out. Okay. And next week onwards, you will find a lot of things to be done for specifically you as well. Okay. Notifications on करो मैसेज आएंगे if you have not subscribed to the channel yet subscribe notifications will come guys so people today is the last lecture for vectors okay this will be the last lecture of basic mathematics you know that a lot of basic mathematics is to be learned before we get into actual physics हमें काइनेमेटिक्स और आगे की फिजिक्स सीखने से पहले बेसिक मैथमेटिक्स सीखना था एंड दैट इज व्हाई वी हैव लर्नड द यूनिट techniques of calculus, differentiation, integration, and vectors as well. These are common topics with mathematics, or rather, I should say, these are actually the topics of mathematics. Okay, so for people who are on the channel for the first time, guys, this is me, your Suri Sir. Yes, this is me, your Suri Sir, also known as Mogambo. Okay, so some people are saying, sir, I am not getting the information. Yes, Shivansh, I can see you, Shivansh Tiwari. So some people are saying that I'm not getting the information, I'm not getting the news and the notification that when is the class happening. So let me tell you what exactly is happening on the channel and when it is happening for you specifically. Yes, let me tell you the daily schedule. And what I want you people to do is अपने cell phones पे reminders लगा के रख लो daily का for the time that is 7 p.m. every day. Okay, every day or at 7 p.m. we meet here to prepare for our JEE and we teach you the theory for JEE examination at 7 o'clock every day. So you can see that on Monday and Friday you meet me. Yup, this is me for physics. On Wednesday and Saturday, you meet Love Sir for chemistry at 7 p.m. And on Tuesdays and Thursday, you meet Arvind Sir for mathematics. Okay. Not just that, guys. 8 p.m. is also an important time to know that this is the time slot when we do MCQs, or you can say only problem solving is done. On Tuesday, you meet me. On Friday, that means today you will be meeting Love Sir after this session. And at on Saturdays at 8 p.m. only you meet Arvind sir. Okay, guys. So for those who people are no you are not aware, then I want you people to put a reminder for 7 p.m. every day to come on this channel. Okay. Good evening once again, everyone. I hope all of you are doing well. And yes, if you are a serious aspirant for JEE 2022, so guys, at Vedantu's platform, we have a specific exclusive batch for all of you running there, and this is the link to join that, and enrollment is free of cost. Yes, you don't have to pay anything. You can be a part of Vedantu's platform as well, where you can see 4,000 plus hours of live teaching is given to you. 40 plus teachers from various different backgrounds are there to teach you all, including me obviously. And Yes, rigorous testing, a lot of assignments, instantaneous doubt solving, and if you miss out on anything, you can watch the replays and recordings as well. So all you have to do is follow this link. This link is available in the description. Okay, what you see here, this link is available in the description of this video. Okay, guys, I hope I'm understandable to all of you. Okay, description is just below this video on YouTube itself. You will find a arrow downward pointing towards the right side of the video. You will click there, you will get all the information, a lot of information. Okay, and if you are on the channel for the first time or not but still haven't subscribed, guys, then what are you waiting for? People, come on, subscribe to the channel quick, right away. Why do you want to subscribe to the channel? Not just subscription, but press that bell icon as well. Okay, there is a small bell icon which you see just next to it. Press that so that you are not missing out on any of the information. Some people were asking, sir, I don't get the information, when is the class happening, I'm not getting the message. Press the bell icon, you will get the notification. Okay, so do subscribe and tell your friends as well. Namaste everyone, namaste once again for those who just now joined us. Cool. So people, today's session is about vector multiplication. So you see, guys, in the chapter of vectors, as I said, this is one of my favorite chapters because this is one of the fundamentals. So we broadly divided vectors, the chapter, into two parts. First was the representation part, second one was the mathematical operations part. Our actual objective is to do mathematical operations only. But before we learn how to add, subtract or multiply vectors, we needed to understand how to represent a vector, how to communicate in vectors. So we learned the representation of the vectors. We learned what? We learned the symbolic, diagrammatic and mathematical representation of the vectors. Then we moved our vehicle to the mathematical operations with vectors. We started off with vector addition. We did triangle law, we did parallelogram law, we did polygon law of vector addition, subtraction as well. And now comes the final mathematical operation of vectors, which we call as the vector multiplication. Okay, so obviously, as vectors are not just numbers, they are physical quantities. So when we were adding vectors, we were getting a vector quantity only. So when we are going to multiply the vectors, we expect physical quantities out of that multiplication. Okay, so guys, when we speak about multiplication, first of all, let me tell you that there are two types of multiplication. First one is called as scalar or dot product. Okay, so first one is called as scalar or dot product. I'll tell you in a while why it is called scalar, why it is called dot product. And second one is called as vector or cross product. Again, I'll tell you very much in detail that what exactly is a vector product or a cross product. Okay. Hmm? Guys, am I audible properly? Guys, am I audible? Guys, quickly tell me if you can hear me properly. Yes? Thank you. Thank you for the feedback. Okay, guys. So, as I said, today we'll be talking about these two multiplications. We'll go to them one by one. Let's go. Cool. So, let's first speak about scalar, and you can also call it dot product. Scalar product or dot product. Let's pay attention, everyone. Okay. So, guys, when do we talk about multiplication, or how do we talk about it to be a scalar product? Well, for that, let me first pick two vectors. So what you see here on the screen, everyone, what you see here is basically your vector A. This is your vector A and this is your vector B. This is something which I told you people that in parallelogram law only, that when we speak about the angle between two vectors, when we speak about angle between two vectors, the vectors must have their tails at the same point or their heads also at the same point. Okay, their tails or heads, both of them should be at the same point, and this is what is the case in this particular situation. So what is given to us that the vectors are a vector and b vector, and they are inclined at an angle theta. So we say that the vector multiplication, which is what we call as scalar product, is represented like this: a dot b equal to a b cos theta. So this is basically what we write scalar or dot product as. Now let me clarify the things first before we go forward anywhere. Why do we call it dot product? let me first answer that. Why it is called a dot product is because when you are looking at the two vectors here, a vector and b vector, you know them symbolically, they are a vector and b vector. You can see that the multiplication sign which is there between them is represented by a dot. That's why it is called a dot b or dot product. Okay, very simple reason, because of the dot which is there, that is why we call it the dot product. Please remember, unlike numbers where we say that 2.3 is 6 and 2 cross 3 is 6, in numbers it doesn't matter. When we are multiplying the numbers, it does not matter whether you are putting a dot in multiplication or a cross in multiplication, does not matter. But in the case of vectors, it is going to mean different thing now. So when we write a dot b, it means a particular type of multiplication. Okay, now why we call it scalar product? Why we call it scalar product is because what you see on the right side here is basically a scalar quantity. It's going to be a scalar. What you see here, a is basically the magnitude of vector A. Okay, what you see here is B, which is the magnitude of vector B, and cos theta, you know, that is a number. So left hand side you have vector A and vector B getting multiplied as dot product. On the right hand side, what you are getting is basically a number whose magnitude is A into B into cos of theta, which means what? It is going to give you an output as a scalar. That is why it is called as a scalar product. I hope basic thought is clear. Because vectors are represented by a dot in multiplication, that's why it is called dot product. And because the output is going to be a scalar thing, that's why we call it a scalar product. Okay, obviously in physics we are going to come across quantities which are going to be the result of dot product of two vector quantities. Okay, I will tell you by the end only that the quantity which is actually a scalar but is a result of multiplication of two vector quantities as dot product. Okay, let's go forward from here. First try to understand further few more things about the scalar or dot product. So important points about dot product here: for vector a and b inclined at an angle theta. So if you see that it all depends on cos theta now with respect to the positivity or negativity of the dot product. If the angle theta between A and B is acute, so you know that cos theta is going to give you positive value. Cos theta between 0 to 90 is going to give you a positive value. So definitely the value of dot product is going to come out to be positive, because on the right hand side, when you look at A dot B, on the right hand side you have magnitude of A multiplied with magnitude of B multiplied with cos of theta. So it all boils down to cos of theta. So if this value is positive, dot product is positive, and that is possible when theta is something between 0 and 90 degree. 90 excluded obviously. And if theta is obtuse angle, which means what? An angle which is greater than 90 and could be till 180 degree, any value, then cos theta will come out to be a negative value. You know that second quadrant. So that's why the overall dot product will come out to be negative. Okay. And if A and B are in the same direction, then what will happen, particularly the angle which is 0 degree, we know that cos of 0 degree is nothing but 1. That's why the value of A dot B will just be the product of magnitude of A and B. Similarly, if the vectors are just opposite in direction, okay, so first case was this, second case is this, then the value of theta is 180 degree and cos theta will become minus 1. Cos 180 degrees minus 1. So that's why your dot product will come out to be minus of A into B. Okay, it's a special case. Means if I say this is a special case of acute angle and this is a special case of obtuse angle. Okay, and what if the angle is 90 degree? If the two vectors are perpendicular to each other, it's a very useful point. Sometimes it's going to be very useful in problem solving in physics. If vector A and B are perpendicular to each other, then the dot product will come out to be 0. So if ever we want to check whether two vectors are perpendicular or not to each other, if the two vectors are perpendicular to each other or not, we'll just check out their dot product. If that value comes out to be 0, without any hesitation, we'll say that the vectors are perpendicular to each other. Okay, okay, cool. Now, continuing with important properties. If you calculate the value of A dot B or you calculate the value of b dot a. I'll tell you how we calculate that also, don't worry, give you example as well. So if you take the dot product a dot b or b dot a, it's going to result in the same thing, and that is going to be a into b into cos theta, because it is a scalar thing. Okay, what do we call it? We call it the commutative property. In mathematics we know this, right? It's called commutative property. And if we take vector a's dot product with vector b plus c, b plus c is basically the resultant of vector b and c, vector addition of b and c. So if you write a dot b plus c, the result of this thing is equal to a dot b plus a dot c. That means you can multiply vector a inside and multiply with b and c both. So individually the value that you will get a dot b and a dot c, if you add them, you are going to get the same result, which we call as the distributive property. Okay, great. Okay, I can see some of the students have joined just now, so welcome everyone, not a problem. Let's continue. Okay, now I would rate this as one of the very important usage of dot product is to find out the angle theta between two vectors. Means what? If you know the value of a dot b, if you know the magnitude of a, if you know the magnitude of b, then you can easily find out the value of cos theta. What is cos theta going to be? Just take the dot product a dot b value divided by the magnitude of a and magnitude of b, and you are done. You will be able to calculate the value of theta. If it comes out to be a value which is say 1 by root 2, you can say that theta is 45 degree. If it is coming out to be 1 by 2, you can say it is angle 60 degree, like that. Okay. Okay, Rahul, thank you. Rahul Shukla, thank you. I'm very happy that you are liking Vedantu's app. Great. Okay, now coming to the understanding that what exactly dot product means. Okay, geometrically. So when we write, say, dot product of a and b, and you write it as a dot b equal to a and then in bracket b cos theta, means what? You are just taking the same dot product a dot b as a b cos theta, but one time you are separating a cos theta, second time you are separating b cos theta with the other one, just in the bracket for our visual part of it. But what does it actually mean? So when we write this b cos theta, if you remember, in the previous session only, I told you people about the resolution of the vectors. So if you will look at it properly, guys, this actually means to find out the shadow of vector b on vector a. Means what? It is nothing but what we call as the projection of vector b on vector a. If you will think about it properly, agar dhyan se sochoge, so what does projection means? Projection is basically getting the shadow of something on a screen. So if you look at b as the object and a as a screen, so what is the shadow of vector b which is being formed on vector a? The length of that shadow is nothing but b cos theta. So with the help of dot product, I can find out the value of b cos theta, which is the projection of vector b on vector a. I can find it out as a dot b divided by magnitude of a. As simple as that. Okay. So you just have to find out the value of a dot b divided by the vector magnitude a. You are getting value of shadow of vector b on vector a. Okay. Similarly, if I have to find the shadow of vector a on vector b, vector a का shadow अगर मुझे vector b पे पता लगाना है, which I will say is going to be a cos theta, nothing else. So this will be called the projection of vector a on vector b. Okay, means what? Say if this is that vector and this is the screen, so what is the shadow of the vector on my hand being formed? That's basically projection of the vector on the other screen, or you can say on the other vector itself. Okay, so if you want to find out a cos theta, all you have to do is a dot b divided by vector b. You can try taking vector a here, taking vector b here, you haven't changed anything. Just be careful when you are looking at what you are finding. This is b cos theta, projection of vector b on a, and this is a cos theta, projection of vector a on b. Okay. Okay. Now guys, if you actually have to take the dot product of say two unit vectors like I cap and I cap, so what will that value be? If you ever have to find out I dot I, j dot j, k dot k, you know that these two vectors I vectors, j vectors and k cap vectors, they are along the same direction. Two I cap vectors will be along x axis, right? This is I cap, this is I cap. Two j cap vectors will be along y axis, right? Similarly, two k cap vectors will be along direction that is coming towards you. So angle between them is 0 degree, and their magnitudes individually you can see is 1 because they are unit vectors. So according to the understanding of dot product, which is a dot b, it is a b cos theta. So what is the value of a? It is 1. What is the value of b? It is also 1, and this is cos of theta that you are writing, which is 0 degree. So remember, the value will always come out to be 1 for the dot product of I vector with I vector, or I cap with I cap, j cap with j cap, k cap with k cap, because the angle is 0 degree and their magnitude is 1. But what if I take the dot product of I cap and j cap and k cap and I cap? You know that they are perpendicular to each other. Yes or no? This is I cap, this is j cap, and this is k cap. So they are mutually perpendicular to each other. So in that case, obviously the value of dot product will have a cos theta 90 value involved, and that value will come out to be 0. So please remember, I dot I, j dot j, k dot k is 1. I dot j, j dot k, k dot I, that value is 0 always. Okay, cool. Okay guys, now let's try to apply the same thing over here. So I want to take the dot product of vector A and vector B, and I want to find this out. So what I'm going to do, I'm going to take the dot product of vector A with vector B. That means I'm going to do this A vector and B vector dot product. That is basically multiplying AX with BX, BY, BZ. Then I will multiply AY with BX, BY, BZ. Let me write it here. Maybe it will help you understand. It is AX I cap plus AY J cap plus AZ K cap, and I'm going to take the dot product with BX I cap plus BY J cap plus BZ K cap. Okay, so let's try that. So what you see here, first I'm going to multiply AX I cap with BX I cap, then next is AX I cap and BY J cap, next is AX I cap with BZ K cap. Okay guys, similarly AX is multiplied with all of them. Now what I'm going to do, I'm going to take AY J cap, multiply it with BX I cap. All the components of A will be multiplied with all the components of B. Okay. Next is AY J cap, BY J cap, and last is AY J cap and BZ K cap. Okay. Now multiplying AZ I cap, this component, sorry, AZ K cap, my mistake. Okay, so AZ K cap is now being multiplied with all the components here. So AZ K cap multiplied with the BX I cap, then AZ K cap multiplies with BY J cap, and last is AZ K cap multiplies with BZ K cap. Now what you see here, people, let me just highlight this part to all of you. What you see here, this is I cap multiplied with I cap, means two vectors which are along same direction multiplied. This is also J cap multiplied with J cap, and this one is K cap multiplied with K cap. Apart from that, what you see, I cap multiplied with J cap, I cap multiplied with K cap, J cap multiplied with I cap, J cap multiplied with K cap with I cap, K cap with J cap. And you know that from our previous slide, what you see here guys, what you see here, that whenever I am going to multiply I cap, J cap, J cap, K cap and K cap, I cap, the value is going to be 0, okay, because they are vectors which are perpendicular to each other. Okay, so now that's what we are going to say, that here in this case the value that you will effectively get A dot B is going to be AX into BX, and angle between them is cos of 0 degree. Then you have AY, BY, also angle between them 0 degree, and AZ, BZ, angle between them is also 0 degree, and it's a value which is I cap dot I cap, which is 1, j dot j cap is 1, and k cap is also 1. Okay guys, that's why every other part I cap multiplied with j cap means be it ax I cap, by j cap, ax I cap, bx bz k cap, all of these values are becoming 0. Okay, what you are left with is only I cap components multiplied with I cap, or you can say ax I cap, bx I cap. These are the only two vectors which are along the same direction. Ay j cap, by j cap are the only vectors which are along the same direction. Okay, so what you see here guys, ax is being multiplied with bx, ay is multiplied with by, and az is multiplied with bz along with the sign obviously. So what you are getting overall as the result of a dot b, my dear friends, if you can keep this in mind, is ax bx plus ay by plus az bz. This is basically the result of dot product. Now what I want you people to keep in mind is that here I have considered that the angle is 0 degree. The other possibility is anti-parallel vectors also, I cap and minus I cap. So whenever that possibility is there, you will have negative directions. So accordingly, for ax, bx, ay, by, az, bz, whatever is the sign, positive or negative for the vectors, we will take care of that. Okay. Cool, we will take them into account. Let me show you how. So what you see here, that vector P and Q are perpendicular. With the help of example, let me show it to you all. So these two perpendicular vectors will definitely have the value of P dot Q to be 0 for sure, because they are perpendicular. So we have to find the value of A. So here what is going to happen? Px Qx plus Py Qy plus Pz Qz should be equal to 0 for you to look. This is what I am applying. Both x components, y components and z components being multiplied together. So if you see, Px is A, Qx is also A. Next is Py, that is A, and Qy is minus 2. Next is Pz, that is 3. Okay, and Qz is minus 1. Let's take it and equate it to 0. So I have a square minus 2a minus 3 equal to 0, and you can say it is a square minus 3a plus a minus 3 equal to 0, just factorizing it. So a minus 3 plus 1, a minus 3 equal to 0, and from here if you will simplify, you will get a equal to 3 or a equal to minus 1. So both possibilities are correct. Okay guys, very good. Benam Gaming got the answer right, very well. It's either 1 or minus 1 or 3. Very good guys. Okay, now guys, this was the first type of multiplication which we call as the dot product. Now comes the second type of multiplication, which is called as vector or cross product. So in the case of scalar or dot product, I told you the outcome is scalar. So obviously here when two vectors will multiply, the output is going to be a vector quantity. Okay, that reminds me of one more thing to give you an example, that work done W is basically the dot product of force and displacement. That's basically the physics example for you. Force is a vector quantity, displacement is a vector quantity, then dot product will give you a scalar quantity called as work. Not get into the detail of it right now because we haven't studied the physics behind it. We will study it in a separate chapter called as work, energy and power very soon. Okay, so that will happen and we will come and get into the details of this dot product physical example. Okay, so guys, now coming to vector or cross product, let me tell you what is happening here. So you have two vectors, vector A and B, which are inclined at an angle theta with each other. They are obviously in the same plane. So we say that their cross product is another vector. So A cross B results in another vector, vector C. You can name it vector C, whose magnitude is A into B into sine theta, and its direction is given by a unit vector n cap. Okay, what is this direction n cap? This direction is a direction that is perpendicular to both vector A and vector B. This is basically your AB sine theta magnitude, and it is perpendicular to vector B as well as perpendicular to vector A. Means what? If you think that vector A and B are in xy plane, giving you just an example. If vector A and B are in xy plane, then the direction that is perpendicular to both of them is basically this or this. So these are the possibility for the direction of vector A cross B. What is happening here? Because of the cross product, you are getting a third vector whose direction is a very specific direction. Okay, that is why it is called as a vector product, because the output is a vector and the magnitude is given by A, B sine of theta. What is theta? Angle between vector A and B. Okay, and what is the direction of this vector? Direction perpendicular, mutually perpendicular to vector A as well as vector B. Okay, and why it is called cross product? As you can see here, the representation of the multiplication of A and B is given by cross. So again repeating, now in physics, A dot B means something else and A cross B means something else. These are two different things for us now. A dot B will result in a different quantity, A cross B will result in a different quantity altogether. Okay. Now, how do we get the direction of this vector C practically? So if you use right hand thumb rule, if ever you are finding A cross B, what does it mean? It means trying to rotate vector A towards vector B. So right now when you are looking at the screen, take your right hand, okay, take your right hand and curl your fingers in such a way that line A is rotating towards line B. Okay, sense of rotation, what you will feel is going to be right hand thumb rule sense. So in this way your thumb should point upward. Okay, that means what? If vector A and B are lying in this hands or this palms plane, then what will happen? A cross B is the situation which is right now like this. Okay, maybe in the video right now you might be looking at the diagram or rather my own video as my left hand, but this is mostly because of the mirror image formation of my video. Okay, are you getting it, guys? Look at the screen here. This is how A and B are being multiplied as A cross B. What does A cross B mean? Let me write it for you. Rotate vector A towards vector B. Okay. Hmm. Similarly, if you are getting this direction, that this is the direction in which thumb is pointing perpendicular to vector A as well as B, have a look at the direction of B cross A, everyone. This is basically the direction of B cross A, which is basically telling you if you curl the fingers of your right hand according to B cross A, means what? Now you try to rotate vector B towards vector A, you get the direction of vector C, which is basically B cross A. Okay, and it is again perpendicular to both vector A and vector B. So what does this mean? This means rotate vector B towards vector A. Okay, everyone? I hope it's understandable. Hmm. Now, important points. Let's rush to them quickly. Vector A and B, if they are collinear, if this happens, if your vectors are parallel to each other, like this or like this. If this is the case, vector A and B, if they are parallel or anti-parallel, then what will happen? Sine theta value come out to be 0. And if sine theta is 0, that simply means you cannot rotate two vectors which are already along the same direction. Okay, so that's why the cross product will come out to be 0 for two collinear vectors. Okay, but if they are perpendicular, then you will have the maximum value of sine theta, and in that case sine theta will come out to be 1, and cross product value will be A into B with a direction again perpendicular to vector A and B simultaneously. Okay, guys. Now, next property, obviously what you saw in the diagram here, what you saw that if vector A cross B was going upward, vector B cross A was going downward. That means they have the same magnitude AB sine theta, but they have different direction. That is why they are basically opposite vectors. Okay, guys. A cross B is equal to minus of B cross A. So the distributive property does not work here. Okay, their magnitude is obviously same, AB sine theta, but their directions are just opposite to each other. Next one, distributive property works here. A cross B plus C is equal to A cross B plus A cross C. Okay, this property will always hold true. Now, if you have this situation, let me just try to give you a visualization here. Let's say this is your I cap, this is J cap, this is K cap. If you try to rotate I cap towards I cap, J cap cross J cap and K cap cross K cap, what will happen? The angle between two collinear vector is 0. So that's why the output will always be 0, unlike the dot product case. But in the case of cross product, this is what will happen. If you will try to rotate I cap towards J cap, that means I cross J, the output will be K cap. You can try your finger, right hand thumb and right hand fingers. Use your right hand and try to curl it as per the diagram that I have drawn. If you will rotate I cap towards J cap, guys, if you will rotate I cap towards J cap, you will get the direction of thumb towards you, which is direction of K cap. Okay. Similarly, J cap cross K cap will be I cap and K cap cross I cap will be J cap. You can learn it like this, that if I rotated towards J, you get K. If J rotated towards K, you get I. If K rotated towards I, you get J. And if opposite is done, then minus J cap, minus K cap and minus I cap. I want you people to take a screenshot right now for this particular slide. Okay, so that you can understand what is happening here. You are basically trying to rotate first vector towards the direction of second vector. Use your right hand and look at the direction in which your thumb is pointing. Please remember, this is how your I cap, J cap and K cap work. So try to rotate one vector towards the other one. You will see whether you are going towards K cap, minus K cap, J cap, minus J cap, K cap, or I cap or minus I cap. Okay, good guys. Now let's have a look at the mathematical form. So if you want to find out the cross product of A vector and B vector, just as we did the dot product, this is what will happen eventually. Means what? You will multiply AX I cap with BX I cap. You will multiply AX I cap with BY J cap. And you will multiply the same AX I cap with BZ K cap, and you will get the first line that you see here. AX I cap cross BX I cap, AX I cap cross BY J cap, AX I cap cross BZ K cap. Similarly, you multiply AY J cap with all the three components of vector B, and you multiply AZ K cap with all the three components of vector B. क्या किया हमने? वेक्टर A के तीनों कंपोनेंट्स को इंडिविजुअली एक एक करके वेक्टर B के हर एक कंपोनेंट से क्रॉस प्रोडक्ट करते हुए मल्टीप्लाई कर दिया है. ओके, that is why we are getting such 9 terms here. So total 9 terms are we getting, and in this, as you know, I cap cross I cap, J cap cross K cap, J cap cross J cap, K cap cross K cap, these values will be 0. That simply means this value is going to be 0, this value is going to be 0, and this value is going to be 0, because these are vectors which are along same direction. Okay, and I cap cross J cap will give you K cap. All these fun days that we will use from here, these are the values that we are going to use handy. And when we do that, eventually what we get out is this: AX I cap BY J cap multiplied to give you K cap direction. Similarly, AX I cap BZ K cap multiplied to give you minus J cap direction, so on and so forth. Finally, a very ugly looking lengthy expression is what you get. A very lengthy expression is what you get. Somebody is suggesting, like Sheila is suggesting in the chat box, to use a different method called as the determinant method. So I don't want your focus on this particular slide, rather I want your focus on the next slide, guys. Let me tell you how we are going to get to the same result in a shortcut form. So what I've done here, if I'm interested in finding A cross B, I've written a determinant in the two parallel lines. I've written first I cap, J cap, K cap in the first row. पहली line में मैंने I cap, J cap, K cap लिख दिया है. In the second line, I'm writing the components of A vector, which is AX, AY, AZ, and in the last line, I'm writing the three components of vector B, which is BX, BY, BZ. Doesn't matter if any of the component is 0, you will put it as 0. Okay. Now, what I'm going to do now, pay very close attention. I'm interested in writing the I cap component. When I'm writing I cap component, I will start moving diagonally downward like this. So from I cap, diagonally down is AY. multiply AY with BZ. Are you getting it? I'm going diagonally downward. Multiply AY with BZ and then AZ with BY. What did I do? I multiplied. First I started from I cap, started moving diagonally downward. I reached AY multiplied with BZ and then AZ multiplied with BY in a cross. You can look at this way also. So you will write it as AY multiplied with BZ. So that is AY BZ. Put a minus sign and then AZ multiplied with BY. Okay, this is your I cap component, by the way. Okay, to write J cap, I am repeating the I cap and J caps here. So what was I cap? It had AX and BX component, and this is AY BY component. So now I'm going to write J cap component, everyone. Again I'm moving diagonally, so I reach AZ, multiply AZ with BX and AX with BZ. So let me write that. So I have AZ multiplied with BX, put a minus sign after that. Remember, you always put a minus sign here in that determinant method. And then AX multiplied with BZ. This is your J cap component. Okay. And lastly, for writing K cap component. So for K cap also will move diagonally downward. You will meet AX multiplied with BY. You will meet AY multiplied with AX, forming another cross. So AX multiplied with BY minus AY multiplied with BX. This is your K cap component. You can match it with this one. AY BZ minus AZ BY I cap, which is what is here also. You can match all the other components. Okay, got it, guys? I know you might still be feeling that what exactly sir has done, so I will give you an example to close the deal. Okay, everyone? Yep. So let's understand this and try to find out A cross B. So to find out A cross B, what you will do, you will draw a determinant. You will write I cap, J cap and K cap in the very first row. Then what do you see? This is your vector A. It has component 1, -2 and 4. So you will write it as 1, -2 and 4. This is your vector A. And vector B is 2, -1 and 2. So this is 2, -1 and 2. As you saw in the previous slide, I will write I cap and J cap one more time. I cap is 1 and 2. J cap is -2 and -1. Okay. So now let's try to write our vector A cross B. So I cap, I want to write down. To write down I cap, multiply in the cross fashion. So start moving from I cap, you reach -2, multiply it with 2. So -2 and 2, when you multiply, you get -4. Put a minus sign. Now you multiply 4 with -1, which is -4. 4 multiplied with -1 is -4, and already a minus sign is waiting outside, so that's why it will become plus, and this is 4. This is your I cap component. Okay, guys, what did I do? Multiply 2 with minus 2 with 2 and 4 with -1. So this is what I get. Now to find out the value of J cap, I'll go to 4 multiplied with 2. So put a plus sign here, and then 4 multiplied with 2 will give you 8, and then 1 multiplied with 2, put a minus sign, 1 multiplied with 2 gives you 2 only, and this is your J cap component. Okay. Cool, guys. Next is K cap. So K cap, for that 1 multiplied with -1 gives me -1, put a minus sign, and then -2 multiplied with 2 gives you -4, so overall this becomes +4, and this is your K cap component. What did you get? Okay, Siddharth, I think you got the value correct. This is 0 I cap plus 6 J cap and plus 3 K cap. This is what we get as A cross B. This is basically our answer. Now what I want you people to check as homework, try A dot C, let's call this vector as C vector. Try A dot C, what you get. Try B dot C and tell me what you get. Okay. Try to find these values and tell me in the comment section that what did you get when you try to do the dot product of vector A and vector C, vector B and vector C. What is vector C, by the way? Vector C we have got as 0 I cap plus 6 j cap plus 3 k cap. Okay, tell me if you are getting the answer as 0 or not. Okay, we cannot change the order of the components. We cannot change the order of the components. If you want to say, if I'm writing A here and B here, you have to write A vector here and B vector here. If you are finding B cross A, then you will first put B and then you will put A. Okay, very good, Alim. So guys, if you are on the channel for the first time or you have missed a lot of classes, because these classes are going on since the month of April, so how do I cover all these classes? The question I'm sure you must be, trying to figure out. So all of you people, if you are on the channel and looking for the previous sessions which are being done, so look for the playlist on this channel. Yes, in the tabs you will find the playlist, and what you are looking for is 2022, the series JEEt Lo 2022 for all of you guys. Okay. Apart from that, guys, if you are interested in getting assignments, notes, and daily updates, so guys, let me invite you to our Telegram group. All you have to do is follow this link, which is available in the description of this video, and you can come to the Telegram group as well. Okay, so guys, I hope you guys enjoyed the session. This was the last theory session of vectors. After this, we'll move on to the actual physics part. If you enjoyed it, do hit the like button, people. Share with your friends. Tell them also about the channel, as well as subscribe to the channel right now. Along with that, press the bell icon. Why? You want to get all the notifications. Cool, people. So very soon, Love Sir is going to be live for all of you, and there will be MCQ session for all of you from him. So with only one objective, that even during lockdown, learning won't stop. Keep continuing coming to the channel, keep learning. Most importantly, keep smiling and stay safe. And I'll see you soon, very, very soon. Okay, guys, take care. Bye bye.